And I don't have a whole lot to talk about other than to just tell you how excited I am to have my friend and partner Mark again with us for many of weeks in a row. And Mark, to contrast to what you ranted about, I probably got 10 emails today from people who are in the Eat Free group that have said, how do I get his replays? These are so amazing. I want to get replays. And so, and told them that they can become members of the elite team so they can get replays. So we have an announcement session now and a Q&A that was just really neat on Monday. I screwed up and I actually didn't record it. It's the first session out of almost 100 we've done now that I didn't get recorded. But I've got the question and answer in there, and it was really fun because we talked about Trump systems, by the way, Mark, that Bill Mollison is always talking about, and Lynn, who's on here tonight with us, she was kind of my co-hostess because nobody else would raise their hand and want to go on live. The week before, we had a whole bunch of people that did. So anyway, I'm going to turn it over to Mark, and he's going to talk to us again about graduate level. Now it's me saying it, so they can come back and credit me. Graduate level forced ecology.
I do have a technical question, Wayne, about last week's webinar, because as I was preparing for this one, I do believe I deleted my copy of last week's webinar. So if it exists, it only exists in recorded form in the archive somewhere. So I don't know how to retrieve that. But
oh, we've got it. But yeah, if you're talking about your slides, we could certainly pull them out of that if we needed to at some point.
I don't need them anytime soon, but just to let you know that there's one missing for me. So
got it.
So. Hi there, everybody. Welcome back again. We're going through forest ecology, and I did a minor rant earlier. I'm not going to go too far into it. Someone from this community basically contacted me privately, saying, "Well, hey, who the heck do you think you are? Where do you get the authority to talk about forest ecology? What university has accredited you, and through which university are you teaching us?" It's like, time out. I went to Unity College in Maine, Central Maine. At the time, it was the only 100% environmental college in the country. I graduated in 1985, and back then, anyways, you're officially not allowed to call yourself an ecologist unless you publish a paper like every year, every 3 years, whatever it is, and go to these seminars every summer and give boring speeches. I didn't do any of that. I haven't done any of that. As soon as I got out of college, I've lived this way for the past 30 years of my life. Instead of going to 2 weeks of field camp in the summer and do a statistical analysis on numbers of pieces of rat poop you found underneath a rotting stump, I've actually lived in ecosystems and derived my food, fuels, medicines, fibers, my economic livelihood by living this way. So that's where my teaching authority comes from. It's from the Book of Nature. That aside, I've got like 4 hours worth of material tonight, so we're not going to be able to get through all of it. I'll probably go ahead and run a little long, as if that's not abnormal, right? And also, it's serious soybean combining time out here in southwest Wisconsin. It is dry, and the air is like pure dust. So I've been breathing almost 100% solid GMO Roundup Ready soybean dust for the past week or so on the farm. So my throat's a little rough. I may be eating cough drops left and right. We're kind of wrapping up our session on succession, which is system development through time. How plant communities, how animal communities, how soil food webs change through time, and how they act and react and interact with disturbance. And it didn't advance for me. There we go. Once again, why we are here, why I am here. There's only one solution to 99.9% of the problems on this planet, is we have to turn all of our resources to repairing the natural world. You'll notice I haven't done a lot of politics. I haven't done a lot of doodads, a lot of buy this tool, buy that tool. Our job is to repair the natural world and then train others to help. We have to create the forests. We have to create clean air, food, fuels, medicines, fibers, and create systems that are ecologically sound and economically profitable, because if they're ecologically sound, we can't screw up. We can't screw up if they're ecologically sound. We're going to redesign agriculture in nature's image, By agriculture, I mean growing food, so please forgive me for talking about food quite a bit. Ecological succession is a change of species composition or the replacement of the life in one place over time. It includes the soil, includes plants, includes animals. It involves changes in the biomass accumulation. We'll see some pictures later on, and if I don't remember to say so, please remind me, where there were two sites that are the same age, that have the same appearance, the same physiognomy 20 years ago, that look radically different. They have accumulated biomass differently than one another. And what's interesting, I bolded these ones tonight because these are really important. We need to keep this stuck in our minds, that different successional stages have more or less total photosynthetic productivity. In ecology, productivity means total photosynthesis, converting sunlight into carbohydrates and oxygen. And so there will be certain successional phases, which are called sears. We'll get to that one later. Certain sears have more total solar flux than other ones. And as a person who's doing restoration agriculture, we want to produce products for sale or for consumption. We would like to optimize our ability to capture sunlight and atmosphere and rain. And so succession is a sequential change of all these species, and it never stops. The term climax was once upon a time used to describe like a late successional forest, like it goes there and it stops forever. Well, it never stops. And what's fascinating and what's amazingly powerful here is succession happens with no need for human effort. We don't have to know that it's happening. We don't have to really even have to know how it's happening. It is happening all around us anyways. And if we do learn a little bit about it, we can use it as a tool. We can interact it for higher productivity and a more successful life. Of course, primary succession, ecosystem change on unvegetated terrain. Secondary succession is change following a disturbance. A disturbance is any kind of discrete event in place and time that changes the structure, the species composition, rearranges the biomass, rearranges the earth itself, water, etc. And what I really want you guys to get over and over again, these 4 steps right here, these are really, really helpful to our understanding as land managers, people actually living on the land with the land. There is a distinct phase when our plant community is getting initiated, when it's getting planted. There is a distinct phase after a period of time when naturally some are going to start dropping out for whatever reason. After this settles down a little bit, it progresses quite a ways. Holes will open up and we'll start to get understory reinitiation. New things will come up in the understory, and then eventually we'll get to this mature system that has almost all age classes represented, everything from early successional stuff that looked like way back at stand initiation, all the way up to the gigantic, huge, old trees that will be the legacy for the next generations. We start, of course, with disturbance. We don't necessarily have to start with disturbance. Disturbance happens. It happens all the time, all around us. As a real estate investor or a person who wants to get onto a piece of land, sometimes land that looks like this is the most affordable to get. I started by buying clear cuts up in Maine because they were very, very inexpensive. The owner would do it without even checking the bank. So for $150 down payment and an owner contract between us and the owner, we could buy a clear cut that looked worse than this, actually. So the disturbance rearranges the system. A lot of biomass has disappeared. It would have burned off if it was a fire. Permaculture guys drive by and drop seed balls at you, or tree planting crews come through and plant trees. A number of different ways for the stand to get established. And as the stand is getting established, more and more of the available growing sites are taken up. Of course, if we're going to be planting trees, we are participating in stand establishment. When you have a disturbance right here, this would be the perfect time to get in here and set this system up ahead of time. If you become the advanced regeneration in the system, your plants are there to change the conditions, start shading things out, start competing for resources, start dominating the site and going in the direction that you want to go through time. Advanced regeneration, I already used the term, are seeds, roots, propagules, stump sprouts, plant propagules that were already in place so that as soon as this disturbance stops, they're immediately going to come back. Once the system is stocked and fully stocked in certain areas, there will be competitive effects between plants, and some will just start to lose. They'll start to die and fall over. There was actually a comment I got from somebody. It was a really well thought out series of questions, but basically the person was at a point of frustration. It's like, look, I originally wanted to get into doing apple orchards, so I'm going to do organic apple orcharding. And then while I'm learning about organic apple orcharding, I hear about permaculture, so I start going down the permaculture path. I'm learning all this stuff about permaculture. Well, now I'm getting into this forest ecology kind of thing. It's just so much stuff to know. It's overwhelmingly, I can't do this. This is too much. And what I want to say about this is everything that I've showed you so far happens without human intervention. Disturbance can happen without human intervention. A volcano, a landslide. Stand initiation happens because seeds come in somehow. Well, then after the site is fully colonized, there will be stem exclusion. So some of the power of doing restoration agriculture, of imitating the plant communities of your place, is the fact that these are the species that belong there. And if you just set them up, you walk away from it, it's going to do okay. It might look like this, and if somebody who is an orchardist looks at this picture right here, they'll flip out. I mean, they'll throw out, look at all the disease that's in there and the pests that are in there. You can't do anything, blah, blah, blah. But you know what? This is a highly productive system. This is about as natural as you can get. And aside from planting trees at the beginning, if you planted trees at the beginning, this probably cost nothing to anybody right here. It's a very affordable technology. All we're doing is imitating nature. So it's so much easier than orcharding, whether it's chemical or organic or permaculture. We don't have to think about these processes. They're going to happen anyways, whether we interact with them or not. However, this is a very useful stage to interact with. This is a direct seed planting that I had done. It's probably around 12 or 15 years ago. A wide variety of oaks, walnuts, and hickories were thrown in there. The site was planted into an old hayfield. A friend and I had basically modified an old corn planter and have come up with a one-row seed tree or tree seed planter that just plants them right in, just like a corn planter. Since it was paid for with a grant, it became public domain and not a patented piece of equipment. And it's now, I've seen this thing, that kind of planter all over the place. Nowadays, Southwest Badger RC&D Council has one of these things and rents it out to people to plant trees. So all we did is we gather up a couple of bushels of nuts. What does that cost? You spend an afternoon in the park with your kids picking up a whole bunch of seeds, throw them in the hopper, drive back and forth through the field, and then walk away for 10 years. What happens naturally all by itself is, look at these gaps in the row. There's like a big gap over here. This is like a row, and then there's a row there, and so on. The rows are about 6 feet apart, and then there's no trees right over here. Maybe mice got in there, started tunneling through the crack, maybe wild pigs, maybe deer. Actually, the first time I've ever seen deer put their nose in the ground and root like pigs was in a direct seeded planting. So now this stand of young trees is at the stem exclusion phase, whether we interact with it or not. If we do nothing to it, the trees that have managed to get a big piece of canopy will start to chemically dominate the others. They will also, their roots are more developed. They'll start to shade out the others. They'll take more moisture and nutrients from the ground. Like, look at this poor little bugger right here. This is losing. It's not going to make it up there. This one already fell over. So we don't have to participate in this at all. Or at the stem exclusion phase, we can participate and help to keep the trees in their fastest phase of growth, those nice, teenage years. And so what we can do, we can come through here and let's say we do a 50% removal. Let's take the ones that are shading this out the most. Let's take that one out of here. It's kind of crooked. It's good for firewood. This one's leaning. It's out in the middle of the road. It's probably going to hit me in the tractor if I drive by. Let's take that one out. It's probably just about big enough for mushrooms. Let's take that one out. It's kind of scrizzly. So then we'll have like these two left behind to continue to grow and colonize the canopy. We can remove these trees almost forever, a little bit at a time, a little bit at a time, as they get bigger and get more light, more water, more nutrients to the trees. Which tree do you think here probably has more wood? Hello, ding, ding, ding. Which probably is straighter? Ding, 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 can make more boards. Will probably make more nuts over time, etc. So we can select for the trees that we want to dominate that site, and let's keep them in that phase of rapid growth. And there's somebody knocking at the door, and the door is locked, and I'm not letting them in. If we keep them right at this phase, we can keep them at that phase in a closed canopy form, as a closed canopy forest, or open in a savanna form with the grass underneath. I'll show you pictures of both. And it depends on our goals. But to keep our trees growing in this phase right here, that's when they're growing the fastest. We're going to be getting the fastest solar turnover, sunlight turned into usable products, and the trees grow faster. This side over here on the left looked virtually identical to this side over here on the right 20 years ago. The difference between the part on the left and the part on the right is, as you can see on the right, it's obviously the stem exclusion phase. There are places where stems are dying, have died already. There's also a lot of prevention of regeneration going on, whereas over here, it was like this picture right here. Whoop. All I did is I kept removing the ugliest, twistedest, the least valuable trees. Keep removing the least valuable trees to give enough light to the other ones to keep them growing as fast as they possibly can. I've just finished for the season in this stand again. I've removed between 1 and 5 cord of wood. That's a pile of wood, 4 by 4 by 4 by 4 by 8 feet long, 128 cubic feet of wood every single year for 22 years now out of this side. And it looks like there's a heck of a lot more wood here than here because there's something going on the right. And we'll talk about that a little bit. This is an example of the stem exclusion phase in an open system. Grass is one of the priorities here, not a closed canopy forest like the previous picture. We want to have grass, and since these are mostly chestnut, I want plenty of sun to strike the foliage of my chestnut trees to optimize the number of nuts that will be on the trees there. And of course, since chestnut is a fire-adapted species, it coppices well, and all these green sprouts are the newly sprouted back from last year's cutting. Here's the area that I just got finished in today. Now, 20 years ago, this tree right here, this was the edge of the woods. Yeah, there's sirens going by, and I wonder if it had something to do with the panic sounding knocking at the doors. It's bizarre. Anyhow, and you see the grass over on the left of the picture here? The grass went all the way up to these trees here. And I didn't do anything because I saw a couple of young trees coming in. We can't really see it here, but in the background there's one tall white ash tree that I've left there behind all these trees. That was there. I saw it was like 6 or 7 foot tall. And so animals have grazed in here for 20 years. Well, eventually, as the stems get closer and tighter together, this is now the stem exclusion phase. These stems have started to die on their own. This one's already started to die on its own. What I did is I went in and I did a removal of material, and I selected for the species that I want based on a number of different criteria. We can't go into all of them, but since this is a farm, I want to have some kind of food, feed, fuel, medicine, fiber, etc. I wanted to, in this site here, favor oaks and hickories because oaks are only mid-tolerant. They won't handle much more shade than this. A couple more years, and these oaks are going to be dead. They'll just give up. They can't grow anymore. There's a lot of black cherry in here. A lot of these lighter leaves of black cherry. It's fairly tolerant, and it can grow in the understory quite well. It coppices back from the root, so it's shade tolerant. Will coppice back from the root. I'm happy to have it there. There's basswood that started to sprout in there. That's a very tolerant species. That'll grow down cellar almost in the dark completely. And so I cut that down because I know it's going to come back. Then there's a lot of sugar maple that was in here, and that's probably not going to sprout back from the root. So I cut it down anyways because I know that as the site gets shadier again, when I open it up, the grass is going to come in. Well, then the trees remaining are going to close the canopy after 4, 5, 6, 7, 10 years. Then the maples can come back in. So I'm not afraid of them disappearing. And then, of course, I left some of the hickories. This is a big, beautiful, nice, straight and tall, about 4 or 5 inches diameter hickory. So since this is at the stem exclusion phase, I'm going to go in and I'm going to exclude the stems, but I'm going to exclude the stems that don't necessarily fulfill my shorter term values, but that I'll have the ones remaining in there for specific reasons. So I went through, cut a bunch of trees. The majority were no bigger than 2-inch diameter, and cut them pretty close to the ground, except for this one. I intentionally left this one about 2.5 feet tall because this was an apple seedling. Probably I was eating an apple and I threw the core over there. It didn't have any fruit on it, and I wanted to encourage it to send up a lot of sprouts. So next season, this 2017, this will send up a lot of sprouts, and in 2018 I can graft on 3, 4, 5, 6, 10 of my favorite varieties and let one of its own branches remain. So now I've got all this debris on the ground, sprinkle liberally with Winecrap stropharia, sawdust spawn that I get from Field and Forest Products, Inc., and drive over it with my flail chopper and chip it all up. So I just have come down here, turn around, and I'm heading back that way to grind up all this stuff in there. This is the great time to get rid of anything that you might consider to be invasives, things that you don't want in a pasture, because all this grass here and whatever remnants of grass is under here, it's going to light back up again, and this is all going to be an open silvopasture system. And just to show you some of the size of the wood, I'm burning as firewood trees that sprouted after I took took over management of New Forest Farm. This is like 15, 16-year-old, I think this at least 16 or maybe 18 once we get to the center here. So these, I'm burning fresh carbon. This is carbon I took out of the atmosphere. It's not a huge thing if I put it back into the atmosphere. I've got somewhat of a closed loop going on. And the trees that are left behind are going to grow faster, and it's going to be oak, which I can use later on for growing shiitake mushrooms, and of course for building. It's an outstanding firewood, etc. And so that's what it looks like, open and clear. And this grass will just easily light right back up. So next year we'll be getting cattle grazing in there, pigs grazing in there. There'll probably be some hickory nuts falling off of the trees. These larger oaks will be dropping acorns again. Maybe we'll be getting some further regeneration of oaks. So we've set up a whole bunch of different values here. Trees that we don't want to completely disappear will come back if they're ones that coppice, and the ones that we want to favor will grow faster because we're giving them more light. And I pulled out of this spot right here a half a cord of wood. So that's 4 foot by 4 foot by 4 foot pile of wood. And our neck of the woods sells for about $80. So for an hour and a half, 2 hours worth of work, I got an $80 value. And the increased value of this property and the resource base that's there, this will feed myself and my family into the future. This is one of the goals I'm looking for there, is an open, grassy, obviously that's been taken later on. There's chestnut in that opening as well, but not too many. An open, grassy piece of property. It's a savanna analog with multiple different purposes, multiple different yields. So once you get to a place, let's go back to this picture here. Okay, now that we're here, and there's been this disturbance, there's been a stem exclusion. I excluded them with the chainsaw, and then I chipped them up with the mower. There's a serious disturbance going on there. There's going to be all kinds of mushrooms here flushing next spring. Now what will happen is all these other trees around will start to drop seed in here, and we're going to get an understory reinitiation. It's going to come back. Certain things like multiflora rose and prickly ash or Tartarian honeysuckle that I don't necessarily want to come back, it's going to come back too. But I'm probably not going to go back to this site for another 10 years because the oaks will dominate, they'll cast a shade, they will kind of steer the system. That's one of the things about plant communities. The dominant, most long-lived elements within the system tend to drive the system chemically and biologically because they're changing the soil with their exudates, their leaf drop, bark shedding, rain that filters down the bark and drips off of leaves, has other stuff on it, and it chemically changes the soil, so only the soil organisms that are compatible with your major tree community will live there. That's why a lot of people say that black walnut kills everything underneath it, is because if black walnut's a site, a pine will pine a site, an oak will oak a site, and if you're not compatible with oak at this site, you won't regenerate. So the understory reinitiation stage, mostly very tolerant, mid-tolerant to very tolerant species. Some of them are so tolerant they can persist just with a few little sunflecks during the day, in the order of minutes of direct sun a day, till we get to the phase of old growth where we have a balance of gigantic old trees and all age classes in between, and some stuff that's freshly disturbed. For example, when a big windstorm comes over and all these big giants fall over and rip up soil and make the pit and mound architecture, we have almost every single phase of succession represented, almost all the species represented from the very, very beginning at disturbance all the way up to the longest lived old growth tree that you have in that system. So then we have an old growth system. Old growth forest, however, may not necessarily, see how it's closed canopy, a closed canopy old growth forest may not be the phase that has the highest rate of solar flux. This may not be the one that produces the most economic return to us or food return to us, short-term cash flow wise. That tends to be in the savanna phase where you've got the benefits of grassland and early successional plants like annual plants, for example, as well as some of your mid to later successional plants. So that middle range tends to have more available solar flux. State University of New York did some research that short rotation woody cropping systems will actually capture 3 to 7 times the energy per acre as a annual crop field does. Short rotation woody crops, they were talking specifically about willow and poplar for biomass to coppice for energy production. But what that means is you've got these fast growing, middle of their age span plants that just have started to close the canopy, and you coppice them, cut them off, and they sprout back. And that's the phase where they're cycling the most energy. That's where we have the most opportunity for economic yields, fruit yields, etc. We can still have our old growth. We'll just have it as part of a mixed, balanced, uneven age distribution of tree diameters in all age classes and all species. Of course, trees may establish and reach the canopy 3 different ways: by following catastrophic disturbance, establishing in gaps in the overstory, by continuous regeneration. These are some older oak trees, old growth oak. This one has died already, left a gap. This now brings more light to these guys here. Now the race is on. The stand is initiated. The understory has been reinitiated. Now it's rapidly going to go into the stem exclusion phase. And we have more opportunities here to interact with it and steer succession in a general direction at that phase. Then, of course, there's continuous regeneration, which we talked a little bit about last week. In an understory, intolerant species are typically the ones that utilize major disturbance mode. The ones that are the most dependent on full sun, they're not shade tolerant. Birch, aspen, willow, cottonwood are classic examples that fly in on little little puffies. Things like box elder, a lot of the spruce, a lot of the pines require disturbed soil, and they utilize this massive disturbance mode for regeneration. The middle tolerant ones can get established and grow quite well in gaps. The size of the gap is going to be different for different species. Oak, for example, will require perhaps a larger or a smaller gap. I don't exactly know what that would be compared to certain West Coast mid-tolerant. I'm going to pick sugar pine because I'm getting ahead to later on in it. It may or may not need a larger or smaller gap. I don't know for sure on that. All of us will. It's in our best interest to research our local plant communities and understand what kind of gaps are needed to regenerate the species that we're looking to regenerate. And we'll come back to this slide because this is really significant. But just imagine here, this is not just a single tree, but it's a row going directly into a screen. And this is a row going directly into the screen. And here's an alley in between. And here's an alley in between. And in this alley, we've got several different species of tree planted in it. Likewise here, all at different ages and stages, different species even. And if we manage the under canopy properly, as well as the over canopy, we can be growing sun-loving plants in the spaces in between these. And then we just manage by removal. And of course, if we make the gap too big or something falls down, we'll put in new species. But we'll come back to that. That's important. Facilitation, tolerance, and inhibition. This needs to be understood. Not everything in the forest is one big cooperative, helpful family. This eastern red cedar, this juniper, was shaded out. It lost the battle for the canopy. It was overtopped by these other species. The branches went right through it. This is actually an American basswood, I believe. Very shade tolerant. It said, I don't care if you got branches in the way. I'm going right through you, right over you, and shading you completely out. You're dead. Those are now my resources. I get that water. I get that piece of sky. That actually does happen. We're going to go through this process a little bit. This happens anyways, whether we're interacting with it or not. This stuff happens. It just does. First of all, there's a disturbance that opens up, a relatively large space. How large? Well, it's relative to the species, the tolerance, rainfall, the soil conditions, all kinds of different things that it's relative to, depending on how big the disturbance is. It's at this phase right here is where our stand initiation happens. Somewhere in here, new propagules come in, seed, cuttings, rooted seedlings that we plant. It came in on animal fur, duck feet, who knows, aardvark poop, however it got there. That's when the stand initiation phase happens. Well, Under the what's called the relay floristics model, with facilitation, what that means is that the species that got established, these early successional pioneer species, they can tolerate the conditions after post-disturbance conditions. And let's just use a cornfield as an example. You've got this cornfield that used to be something else a long time ago, but it's been plowed for the past 60 years and sprayed with herbicide. This is a seriously harassed piece of tired dirt. Only certain species will get established there well, mostly pioneer species. As they grow, they're going to be putting their roots into the soil. They're increasing the carbon, the organic matter in the soil. They are tolerant of a more bacterially dominated soil instead of a fungally dominated soil, whereas late successional species need more fungally dominated soil. I spoke a little bit about the River Edge Nature Center, whereas they'd had a hard time establishing the beech maple that's supposed to be there, because beech maple is a late successional species. It did not like going into a cornfield. So what it needed was some facilitation. Relay floristics is that this suite of species changes the system enough for the next suite of species to get established, which changes it enough for the next suite of species. And so you see the modification of the environment by the early occupants makes it more suitable for the late successional species. Well, then as that gets established, what happens once that site is totally colonized? Earlier species are eliminated through competition for resources. What stage is that? That's the stem exclusion phase. That's thinning. Naturally, the early pioneer species here are going to fade out. Sometimes the pioneer species only live a short period of time. Aspens are a classic in the east of U.S. anyways. Pin cherry, really, you probably never get a pin cherry that grows taller than 40 feet tall, maybe 8 or 10 inch diameter, 60 years old at the most. They grow real fast, they colonize a site, and they die. They've helped to change the site to make it ready for the later successional species that come in underneath. So this is where stem exclusion takes place. Well, a different model, this one over here on the facilitation side, this was let me go back to the term so I remember it correctly. Right, the relay floristics. And then over here, our initial floristic composition model, go back. Whereas the individuals, any species can get established there, and they do. If they follow the tolerance model, the modification of the environment by the early ones doesn't really have an effect on the later successional species. They just kind of all get along to a certain extent. They will go through the stem exclusion phase. They will. Well, on the inhibition side, there is a whole bunch of different sears, like these successional phases. And the shrubland is actually one of them. When you get into a shrubland type situation, it's entirely possible that suite of species can inhibit the further invasion by others. And as long as they are unmanaged, they'll persist forever and ever and ever and ever, and they'll exclude or suppress subsequent colonists of all species. We've talked about that before, and you remember where I was talking about that? I was talking about it in relation to chaparral systems in California. It used to be redwood, cut down. They tried to go through secondary succession again, but then again were cut again. They turned into grasslands. As long as there was lots of burning and grazing, the grasslands were doing all right, but once fire and grazing went away from the grasslands, it all grown up to scrub chaparral, and it's almost impossible to break that cycle without a major disturbance. And fortunately for the chaparral in California, fire comes in every once in a while, but now there's no legacy species to recolonize after the disturbance. So this can happen, and here's an example right here. This one, in the early years at the stem exclusion phase, it got kind of stuck because of inhibition. Certain shrubs and trees got to the phase and they excluded anybody and everybody else from coming in. And so it's not growing as fast, and it's stunted at a stage. And if we remember again, we're talking about successional time. There's forward in successional time, means towards a more developed, more tolerant, shade tolerant system. with a shade-tolerant understory, and back in time is towards disturbance, bare soil, grassland phase. So this has showed at the stem exclusion phase a tremendous amount of inhibition, which has prevented new trees like these from sprouting up. Coarse-tolerant species can use a third mode of continuous recruitment. This is in Michigan at the Warren Woods, and this is a picture I took in Belgium. Just amazing understory. It's like pure solid stand of beech overstory. And then in certain areas, it's just this amazing little stand of young seedlings. Do you think 100% of those beech seedlings are going to make it to the canopy? Absolutely not. Probably not. This is where by planting high density, too many plants early on, and using stun, strategic total utter neglect, as our selection model, we're imitating nature. Nature threw down all these seeds. They all sprouted, but only the one that is most adapted to this site and these particular conditions will survive and thrive and make it to the canopy. That's what we're imitating. And you guys can go back and look at this, because no matter where you are in a stage of succession, you have all kinds of plants that are there to choose from. The decisions that you make will change the composition of that place, of that stand, 20 years from now, 200 years from now, 500 years from now, 1 year from now, by learning the different habits of the different plants and how these different plant communities work as a community. We can steer the succession of our place through time and keep it at a quote-unquote old growth phase once it finally gets there. And we'll have our openings for our early successional plants and our annual plants, everything all the way up to gigantic old growth whatevers. And if we manage that at the landscape scale, how could we screw up if we transform our planet back into a late successional ecosystem with species that are site adapted and regionally adapted? Can't go wrong. Can't go wrong. And we'll eat pretty well too. We talked about this last week, and I'm going to slam through it really quick. 200 miles around it, the Pinion system is one that you can design your ecological restoration agriculture permaculture system around. This is a huge potential staple food crop, massively underutilized. We don't have to go out into natural areas and steal pinyon pines from those poor little starving squirrels. We can grow them on our own properties. I know quite a few people. So here's a late successional closed canopy pinyon juniper dryland forest. What are our options? How can we optimize photosynthetic and biological productivity on this site while minimizing our expense, our cost in doing so? One is we can adapt to the system the way it is, which we know is always changing through succession. We can nudge succession forward in successional time, meaning take it to an even more closed canopy forest where we start getting an understory of shade-tolerant plants. And in this region, it would be mostly Rocky Mountain Douglas fir would start to come in underneath. Or we go backward in successional time and start opening it up, removing the less desirable species, maybe going back one phase to a, let's say, like a gamble oak savanna phase, or even further back to a grassland. Those are our choices. Or we can do the modern agricultural method of just eradicate the whole doggone thing and reestablish a totally different one. Which can you do on your place, which is easiest to do, most affordable for you to do, has the highest rate of returns for you? Which one can you figure out, work with what you got, nudge it forward or backward, or start completely over? Those are your choices. And what kind of disturbance is pinyon adapted to? Fire and grazing. We can imitate fire either with controlled burns or with mowing, which removes a lot of the organic matter and clears off a lot of the space above ground, exposes a lot of mineral soil. It does not, however, consume the energy that's there, and it doesn't have the fast flush release and alkalinizing, what word would that be? Effect of wood ash immediately following the next rain. And of course, grazing. We have all kinds of animals to choose from when they're grazing. So on the grassland phase, if we remember that we're fire, we can overburn it, return it to grassland, just keep burning it at grassland, and grazing it. or get it to a certain stage and then thin some out. Instead of using a thinning fire, how about using a brush saw, which is a heavy-duty weed eater and a table saw blade on it, or one of those forestry mulchers that we saw a couple of webinars ago, or we get it to a nice pole-size stand with grass underneath it, and we maintain this open park-like stand. This is the phase right here where we have the most opportunity for total energy flux, sunlight, and nutrient cycling, and highest potential for yields of saleable products. So here's a property in the historic range of Pinyon Pine. What are the options? What are the options that you have for this property? Young couple who spent the summer on our farm, they may be on the webinar tonight, have property like this in Colorado in the Pinyon Juniper homeland. What do? What does the person do with this? Well, if we were big ag, what would we do? Well, let's see. We would either would have to get our new well permits and drill a 5 million foot deep well, have some kind of electricity to run the pumps and the irrigation system, maybe center pivot, maybe a long line straight pipe that you roll through the fields, or maybe forget that, we'll just go dry land and we'll concentrate on growing a winter wheat or a winter rye, winter triticale, a winter grain, and then maybe in the spring we oversow in the stubble with sorghum sudan, which is an incredibly drought-resistant grass. Hit it with all the chemicals and fertilizers and fungicide and herbicides. That would be a big ag type approach to this property here. That may be what you choose to do. What would like the Holistic Management Saver Institute approach be? Well, you get a whole bunch of animals, more or less depending on the land base, and you programmatically keep them closely confined with one another so they're a tight herd, and you graze the dickens out of a place, and then you move the animals fairly rapidly to the next place, and you leave the space behind, give it a long time before you ever go back to that first field to graze it again. That would work. That would actually increase the productivity here, possibly put you into a positive cash flow situation. What would like a Midwestern bioag soil remineralization approach be? You do a soil test for cation exchange capacity of your various different minerals. You add the particular minerals that are in shortage. It brings the overall level of fertility up. That lights up your soil. Life comes alive. Now you can graze more cattle, maybe in a set stocking situation where you just put them out there and wander them out there. You will get higher yields if you follow the Midwestern bioag remineralization approach. You just will. What would Elaine Ingham do? Some kind of soil biology approach, not necessarily just hers. You make up all kinds of potions from very specific compost. You send soil tests to her. I think it's like $250 a pop. Then you get the proper ratios of fungi and bacteria that you're supposed to have in this mix, and you got the pumps and the bells and the whistles, and then you have that sprayer, and you apply the sprayer, and you put the potions all over the soil at the right time. You will actually show increased yields. The soil food web, will utilize what carbon is in there in the soil, what moisture is in there in the soil. They'll metabolize, they'll produce more fertilizer for your grasslands, and then maybe you can have your cattle on top of that. You will have more productivity. What about like bioenergetic subtle energies, paramagnetism? We put on this special kind of rock, or you put this particular kind of non-material energy field harmonizer. Whatever you would use, you would most likely see some sort of results. All of these techniques are just like bit solutions. They're all different in how they do something, but they're all the same in that they're only looking at a very small piece of the puzzle. What we're going to do as restoration agriculturists, we're looking at the biggest big pictures we possibly can. Is the whole biosphere is what we're looking at. We're looking at the bioregion where it's at. We're looking at the biome, the plant communities. We're looking at redesigning this system to be its most productive ecotype that's possible in this particular area. So what would we do? We're going to learn the historic biome, its plant communities, and then the disturbance regime that kept those plant communities in a good balanced dance. We're going to manage the water resource. We're going to plant some sort of perennial polycultures that we learned in step one, And then we're going to follow the pattern established by the water management system in step 2. Now we're going to manage the whole thing using apropriate agroforestry practices, which we'll talk about many other times and later, alley cropping, windbreaks, hedgerows, silvopasture, forest farming. Then, step 5, we'll fine-tune our system using those other techniques. If we're big ag people, we'll use some of those techniques. If we're holistic managers, we'll use some of those techniques, Midwest bioag, soil food web, etc. We'll use the techniques that are contextually appropriate and help us to fulfill our goals. There are some people on this list right now who are utilizing all the chemical fertilizers, herbicides, fungicides, pesticides, and GMO crops. They are farmers just like I am, and I use none of that. We all need to learn how to be the best farmers that we are, the best way we possibly can, and the way to do that is to imitate our natural ecosystems, go perennial, and then what we'll do is we'll learn how to do less and less and less and less of what it was that we're doing and still have a healthy system. So like the fine tunings right here, I haven't sprayed a thing, organic or otherwise, on my farm in, let's see, I actually did spray for cucumber beetle, I think in 1998 or something like that, because I was tired of losing all of my squash to cucumber beetles at the time. That was the last time. It was organic spray. It was actually rotenone, believe it or not. And then we end up with a system that looks like this. We've got these terraces, and we've got our plant communities on these terraces. Most of these are actually Italian pine. There's a lot of Italian pine, pine-nut pine, similar conditions as pinon. And this little bugger right here, he knows what it's all about. Look, Ma, I got one. Ta-da! Let's do a silvopasture system where we're raising livestock and pines and the other species that are in that natural plant community, which we'll get to. There's a whole host of useful economic species that live right along in companionship with the pines in just about every biome that's out there. What if you got a situation like this? You are seriously right in the shrubland phase, stem exclusion phase, and this is a tricky one because you are at a very inhibitory stage. There's a place I was just at in Texas a year ago, actually, that was a lot like this. There's a place I was at in France just earlier this spring that was like this. This is a real nuisance of a phase to be at because it's somewhat of a challenge to get rid of all of the brush in an economic manner. You can't do it effectively enough with goats. They'll do too much damage to your other residual trees that you actually want. But in here, what if you start with what you got? Start clearing around these pines, clip away some of the lower branches to remove ladder fuels, and get some of this brush laid down, chip it up to allow some more sunlight in there so that these grasses can now reseed. Let's set it back in successional time to a more savanna phase. Here is a similar situation, similar species. This is also our pinyon pine, but this is overgrazed or improperly grazed. Let's go back and remove some of our ladder fuels. Let's lay our branches also crosswise on the slope, so any debris and organic matter will kind of filter down and get caught. I did a series of videos at Wayne's Ranch a year ago that showed naturally where a branch had just fallen across the hillside, and lo and behold, a couple of leaves and rabbit turds and stuff collected behind there, and there's a little micro compost pile going on, starting that virtuous cycle. Let's give this one some rest here. Let's let those grasses have a chance to grow. And of course, it would be nice to pray for rain. And maybe this is where all of a sudden you go get your biodynamic preps and you do a sequential spraying at the right point in time that supposedly sets up a rainfall pattern. It's a very small data set, but whenever I followed a procedure that was set up by Hugh Courtney first about how to make it rain, doggone it, both times when I've done it, it's rained. So, it's either wonderful coincidence or it actually works. And now remember, with the pines, there's over 20 species of pine nut in the world. They're adapted to all regions of the world except for the tundra and bare rock and ice where they won't grow. So here's this map of the globe, okay? See the orange up here, and then the Arctic and then down here, Antarctica. Those are the only places where some sort of pine nut won't grow. I'm willing to bet a nickel that most of you live somewhere within the range of pine. We can be designing systems around the pine nut as our major species driving that system. This is Italian pine in Croatia, pine forest, unmanaged, not utilized as a food source. This is actually in one of the regions where it never used to be, but it is now the largest pine nut growing region on the planet, and that's the Russian Far East. So this is parts of Siberia. Those of you in northern Canada in the boreal forest biome or higher elevation, you guys know what this looks like. All the evergreen trees in the hills of the mountains or the evergreen trees on the flat. Well, instead of black spruce or white spruce or Engelmann spruce, they have Siberian pine, which makes pine nuts. And they're making a booming business in pine nut oil and pine flour and the pine nuts themselves, to the extent that there's actually been quite a bit of research, and the natural populations of these pines are actually threatened in many places because of overharvesting. People are in this, oh my gosh, we've got this huge resource, let's go get it. And you tap into that resource and you extract it as fast as you can to get the fastest value out of it, and you degrade the resource base. That's not how we want to do it. We want to get into, this highfalutin, expensive crop. Actually, it's a great staple food crop. You only need like one pine cone worth of pine nuts a day, and that's like all the fat calories you possibly need is 60–70% fat. And I'd like somebody who's allergic to nuts to do some research on pine nuts, because I don't know if that qualifies as a true tree nut, simply because it's a different botanical part of the reproductive structure. But we can have high value products like this going out in large quantities, grown in natural ecosystems that we plant. This is for the folks in the U.S. We've talked already a little bit about our pinon region here, and one of the things to notice over here in California, all the way down to Baja California, the pinon pine and this pine over here overlap in range. This part of the range, there's no North American pines that have the large nuts in the eastern part of North America, but we can do a climatological substitution, and down here we could start using some Italian pines in drier areas, and all through here, anywhere that an eastern white pine would grow, all the way up and through Canada, anywhere an eastern white pine would grow, a Korean pine would do really well. This is the family of species, the suite of species that you'll find. This is the plant community that lives with pines. Pines are the oldest, longest lived. They'll drive the system chemically, biologically, etc. But these other species live with it. Beech, cherries, plums, apricots. There's bush forms, tree forms, small trees, serviceberries, saskatoons, Juneberries, or what some other people call them, hazelnut. One of my favorite places is walking up Aspen Creek, or not Aspen Creek, Boulder Creek, coming out of Boulder, Colorado. You just keep walking upstream and upstream. Once you get out of the influence of town, there's beaked hazelnut all along the stream sides, going all the way up to about 8,000 feet. Siberian tea shrub for further up north. There are places where it behaves aggressively. So if you're in like the Middle Prairie provinces in Canada and in the Dakotas, Minnesota, it's now illegal for us to plant in Wisconsin, although it doesn't behave, doesn't like take off and reproduce too fast. But it makes these beautiful little mung bean sized beans. It's a nitrogen fixer. Once it's established, it grows fairly fast. Blueberries. Blueberries are the king. Wherever you find pines, there will be some sort of blueberry or huckleberry that will be growing with pines. Raspberries, of course, blackberries in other places. Lingonberries, which are closely related to the cranberries that we have at Thanksgiving. Grapes in the warmer, moister climates. Wintergreen is a ground crawling little understory plant, super shade tolerant. And of course, fungi, forage, and livestock. This is a natural plant community. These are plants that live together, are happy together, have thrived together for a zillion years. If we go into a disturbed site, or wherever we get to a site first, and just plant all these species there, we can walk away from them and do nothing to them. A lot of them will die. I won't say most of them will die, but a lot of them will die. But they'll sort it out. These guys all belong together. They've been living together for years and years and years, and we will have a perennial food-producing ecosystem that's highly nutritious with fruits and nuts and berries and animals and mushrooms and all kinds of stuff. For those who are in areas that grow eastern white pine, we have at Forest Agriculture Enterprises this year an abundance of Korean pine seedlings. They're generally pretty small. They're about 6 to 8 inches tall, pretty big root system on them. The seeds are a nuisance to sprout, even for a professional nursery guy. So sometimes we have lots of them, and sometimes we don't have any at all. So this is one of the years that we have lots of them. So be sure to get in on the action. If you can grow eastern white pine, you can grow Korean pine. Now, if we remember the pictures from the boundary waters way back at the beginning here, where there were blowdowns, this pit and mound architecture. They would prefer some mineral soil, some disturbed mineral soil right off the bat. They will take 3 or 4 years to get established until they really kick in, and then they'll grow 18 inches to 2 feet a year and start producing really young. I select for Korean pines that start to produce nuts within 4 years as my cutoff on the Korean pines. This is in southwest Wisconsin, a New Forest farm. This is part of my oldest pine nut place. It's got white birch. This is beech in front. This is all Siberian pea shrub. There's prairie roses. There's service berries in there. Then, of course, the pine nuts. You can see a couple of cones up there on these trees, cones up in there. It's time for me to get out and pick them right now because they're all over the ground. And as you see right here, they're starting to get eaten apart by squirrels. 2 of these cones produced about an 8-ounce baby food jar full of the seeds. They're in a hard shell. They need to be cracked. And I've seen an 8-ounce jar of them selling at Steve's Wine Shop in Madison, Wisconsin for $19.99 for this, beautiful little gold foil ribbon and all that kind of stuff. Very high value. And like I said, I want to do the research on it, but I'm willing to bet that maybe 2 pine cones a day is enough energy to keep you going. And they're delicious. I like them. The big deal with pine nuts is I don't see why every blueberry grower anywhere isn't combining and doing a 2-story system of pine with their blueberries. As we see over here, these lowbush blueberries in Maine, they're already being colonized by pines. You see a few lone pines over here. Those are probably pines here. There's at least 1 pine in the background here. In the Northeast and in the Maritimes in Canada, blueberries are grown. Lowbush blueberries, hardly any soil, highly acidic conditions, hardly anything likes it. They're very fire prone originally, and of course managed with fire now commercially. Perfect place for a 2-story pine nut, Korean pine over lowbush blueberry system. And here's a highbush blueberry system to be harvested with a straddle harvester. Why not stick Korean pines in there? It's going to be 5, 6, 8, 10 years before they start to cast any shade, and then you just manage your branches by pruning your branches just before Christmas time to make wreaths, to sell Christmas wreaths with your pine nut specialty item at your roadside stand. Design your system to be machine harvestable. And what I find fascinating about this, look what we see in the background. We see pines, we see pines, we see pines. There's pines over here. Pines and blueberries grow together. They belong together. Why not have pine nuts over blueberries? Well, as a matter of fact, at New Forest Farm in Wisconsin, I do have pine nuts and blueberries. This is the original windbreak planted around the homestead area. So all this area in the left is my pine nut breeding trial zone where I had, I believe it was 7 different species of pine nut that we originally planted, a tree with sheer total utter neglect. And here are 2 of the last Siberian pines that I have that are finally dying like 20 years later, yet to have a cone. So this whole row of Siberian pines just died all by itself. Well, these are all Korean pine. and just like in the windbreak, they're interplanted with blueberry. Put the blueberries, high bush blueberries, right in the row. In my part of Wisconsin, we're on limestone bedrock, which makes a soil that's not quite acid enough for blueberries. So when we get the pines and we get the spruce established, the pines and the spruce tend to push the soil chemistry towards the acid side of things. And so we get outstanding blueberries growing represented in there as well. There's cherries. I actually have some grapes in there. But the blueberry spruce, blueberry pine is just really beautiful this time of year as well. This is probably the last plant community that I'll cover for the night because we're already over time. And this is the sugar pine, all the way from Washington State, all the way down again into Baja de California, Mexico. The sugar pine makes the largest pine cone of any pine on the planet. And they're humongous trees to boot. You know, a couple 100-foot tall, 10, 12-foot diameter trunks, monstrous trees, big, big, beautiful trees. They're mid to late successional. They're not as shade tolerant as the western hemlocks or Douglas fir, for example, but they're more tolerant than many other ones. And there's some of the cones just hanging off of it. It's a lot. Look, the foliage looks a lot like an eastern white pine. What I like the most about sugar pine is that it overlaps, its range overlaps with redwoods and sequoias. So, did I do? Yeah, like look at this picture right here and go back to here, okay? Now, what if we design a 3-story system just with the trees? Let's have our sequoias and our redwoods in rows like this. We know that they're not going to get this big for a long time, but we're going to plant them anyways. Then in between, we're going to plant, like right in the row, we'll plant maybe some Douglas fir because it's shade tolerant and it's going to be designed to grow up in with and underneath the redwoods. And maybe halfway in between, we'll grow our sugar pines. And then as time goes on, we can plant more Douglas fir underneath our sugar pines. So what we have is we have a perfect replica of a natural system. We can have open grass in between, grazing animals, Douglas fir for Christmas trees and Christmas ornaments, sugar pine for pine cones, and redwoods for long-term return on the system. A totally natural system that looks like this based on pine nuts. Man, if we could start getting systems like this growing all the way across California again, that's restoration. And when we're doing it by harvesting yields from huckleberries to the blueberries to the hazelnuts that grow with redwoods, which are beaked hazelnut, to sugar pine, to Douglas fir and redwoods, that's restoration agriculture. And it's a lot of fun. And that's where I guess I'm going to break for the night because it's a beautiful picture.
Good point, good place. Got several questions, good ones. They're always good, but these are even better tonight. Lynn asks, how do you eat pine nuts / pine cones?
Oh, wow. That could be a fun question to play with. Well, the cone itself, I shouldn't be too far away from it if I go back, right? All right, so wherever the cone is, you don't eat the cone. It's the seed inside. And on the ground. Oh, there we go. Korean pine is serotinous, and it's glued pretty well shut. It needs to be heated and dried somehow. So these, you dry them in the sun, they'll open up much of the time. There was one of the guys on a tour this last Sunday, Society of American Foresters tour, says that they open them with boiling water. They dump a whole bunch into boiling water that opens them up, and then they're in a hard shell, just like a regular nut. If you go to the Forest Ag website to buy Korean pines, you'll see some pictures of the seed as it was taken out, and that has to get cracked. Industrially, they're cracked in a big hopper that runs it through the crack or separates the shells out, and then you eat the kernel on the inside. I highly recommend going to the store or go to the grocery store and buying some pine nuts and just try them, eat them out of hand, toss them on a salad, lightly roast them. It really brings out, piney, nutty flavor. It doesn't taste like pine pitch at all. They're really tasty. The pine cones, though, I could have fun with that. How could I eat pine cones? Eat the seeds. And they're bigger. They're much bigger. Some of them are as big as like your fingernail on your ring finger.
Sam Palmer asks for a source for Siberian pine seeds for property in Alaska, and he broadly threw it out to the group. Anyone know of one? A couple people actually answered. So, do you have an answer for that at all, Mark?
Well, I've got a line on some too, and if Sam put an answer out there somewhere, I'd like to see the answer myself because, I've got property in Alaska, and I really think it should be pushed. There's so many places in Alaska that would do really well with Siberian pine.
Actually, Ray put an answer on eBay. It wasn't Sam. Sam was asking the question, and Ray put an answer up. So I'll get it to you, Mark. But and that's one thing, by the way, everybody. We're going to start adding to each one of the sessions this whole question and answer. I've already started putting it on some, but it'll be up here for this one.
But you got to watch out for. What you got to watch out for sometimes, though, if you're getting it from a site that's selling it as food, okay, that's regulated differently as a site that's selling it as seed. If they're selling it as seed, they probably have to go through some phytosanitary permit process, and it has to go from a licensed numbered nursery to a licensed numbered nursery, and a wholesaler has to be the one to buy it. If it's being sold as food, it is probably irradiated. Most of our nuts that are coming in from overseas, even as raw, they've either been irradiated or flash pasteurized, and that can damage their sprouting ability. And if you get the pine nuts, just the kernels to eat, they've already been cracked out of the shell. They may not be viable. I wouldn't rule it out, but just be aware that there's kind of two different categories going on there. There's food and seed.
Joy asks, do loblolly pines have nuts?
All trees have seeds. Loblolly pines do as well. They're just much smaller. And if you have lots of loblolly, you're in an area that probably you can get pinions established, and or sugar pine, or depending on your water regime, definitely Italian pine you can get growing on along with it. And it's very similar growth pattern and soil types that it would tolerate. Yes, you can eat loblolly pine seeds. They're just much, much smaller.
I muted my mic for a second because the train was going by. Adam asks about 3 questions. I think I know the answer to one of them, but I'll ask anyway. What is the textbook you are using? And I'll let you go ahead with that one.
Well, you know what? Tonight is the night that I don't have the primary textbook with me. But the title is Forest Ecology. It's the university text, undergrad text for forest ecology, and it's annotated and updated every 3 or 4 years or whatever. It's funny that this is the first night I didn't bring it with me. But then what I do is in each section as I'm going through, I've got other resource material and a bunch of just different journal articles that I look at. And actually, that's where I get the basic text from. But where I get the real understanding is with working with these systems. Like I said, I've been living this way. I kid you not. I've been growing my own food in ecological systems for 30 bloody years. You get a different understanding of a forest when you are actually part and parcel of it and actively participate in its life. And so, yes, I'm following the text. And if you go back to one of the first or second webinars on the archives, you'll see some of the text that I'm using. Also do a lot of research on restoration ecology, because that has a lot more applicability, I think, to going into sites that aren't currently, like this picture right here that we're showing, that aren't this. What do you do if it's all grass and you want to go here? How do you go through that process? And so a lot of those are listed in one of the first webinars.
There's a second question from Adam. Is it possible to grow 2 very different vegetation types right up next to each other?
Oh, absolutely. Absolutely. How about like right in the same spot? That's the classic permaculture stacking concept, vertical integration, in ecology speak. I've got many just natural examples at my place. I've got cherry and hickory that are growing out of the same hole. They just get bigger and bigger and bigger. Obviously, they're not growing together. They are twisted around with one another. I've got apple and black walnut, which according to most of the books cannot, and will not happen. The apple tree is easily 1 foot in diameter. The walnut tree is almost 2 feet in diameter. I got white ash over hawthorn, right in the same spot. And so in a row, what we'll often do is we'll plant the whole entire polyculture right in the row. And what will end up happening is the short species never grow taller than they grow. The medium species grow a little bit taller than that. The next tallest ones grow taller than that, and the tallest ones overtop it. So you end up with, they sort themselves out by height because they will only grow that tall. No matter what you plant in the same row as this redwood here, it'll never take this part of the canopy because it just can't grow that tall.
Cool.
So yes.
Couple more. You mentioned Korean pines with beech, prunus. Any other trees that will do planted closely with them?
Go right back to the slide, the plant community with the, I'm going to go right there to it and slam it right at you because you axed. But right there. All of those. Now you got other factors that are going to play in here. Beech is going to require a certain amount of moisture per year. The eastern part of this photograph, go with beech, maybe some up north. Hazelnut is basically all across this range. Naturally, I haven't seen it much further north in southern Yukon and Northwest Territories, rarely in Alaska, all through California. But the ones that you'll see in California are beaked hazel, and nobody's done any breeding work with that. It's a huge opportunity for a weed tree to come into our regular part of our food supply. Any of these species right here will go right with them, right in the same patch, happy as can be, if you've got enough water for it and the soil conditions are right, yada, yada, yada.
Here's a fun one, and you must know this fellow, but it says, Mark, it's piezoelectric. Currently working on an urban site populated with 30 to 40-year-old cottonwoods with a prevalent mix of staghorn sumac and some willow sprinkled in. Looking to phase out the cottonwoods with chestnut, pine nut, hazelnut, mulberry in the immediate vicinity, as well as numerous fruit trees and shrubs. And then it just says tips and tricks for transforming this cottonwood-dominated site.
If it's a cottonwood-dominated site, it's probably telling you it's pretty close to the water table, because usually that's what cottonwood does, and it's not necessarily a chestnut site. That might be more of a call for walnut, hazelnut side of things instead of chestnut. If it is a very well-drained site, just start thinning out those cottonwoods, and you know how well they sprout back and come back from roots. Flag cottonwoods in a row, based on some sort of management system, and then remove things in an alley, and then flag another row of them, and leave the trees in the row and remove them in the alley. Then you can start to plant other things within the row as you remove your cottonwoods through time. And oyster mushroom seems to like cottonwood pretty good, so start a mushroom biz.
I'm going to do a couple more here. I think this one, do you sell from the nursery into Canada? Greg says.
Okay, yes, we can. It's a royal pain in the butt. And so what typically we do is we would want to find one person who becomes the point person where everything goes to. So if it's you, Greg, we'll ship to you, but you take charge and responsibility for organizing all of the other Canadians around you, and we'll have to start to dance really soon, like now, if we want to ship in May, to get all the paperwork in place. And then what ends up happening, it's a very real occurrence, what ends up happening is that inevitably, just because they feel that they have to do it, they will reject a box or two and send it back. And so we want to start the process now, get a whole bunch of people involved. A commercial nursery would be nice to be involved with one of them. And typically we've shipped out of either Montana or Michigan to bring trees into Canada, nursery to nursery. So yes, we do ship to Canada. Call Karen at Forest Ag and volunteer to bring in half a truckload of trees and distribute them to all the different people that sign up to buy trees in Canada. So yes, we can ship to Canada.
Okay, last question for tonight. And by the way, I'm going to post these, like I said, and we'll get Mark to answer any of the others that aren't answered. Are you growing any beaked hazelnuts? I believe that's the species that grows wildly in the Canadian prairies. So,
I am growing beaked hazelnut and growing pure beaked, pure American, crosses between beaked and American, crosses between all of those plus European. I'm growing these mutts, and now on my site they've sorted themselves out. And what happens is inevitably I'll start to see a lot of clusters that look like beaked hazelnut. So the hybrid hazelnuts that we sell, that's the biggest, widest gene pool set of mutts that we have, and I know that they're growing up in Alberta, they're growing in Fairbanks, so they're doing pretty well. I think there's some in southern Manitoba, not northern Manitoba. But if you're anywhere between the lakes, I've seen hazelnut is way up into Ericdale between the lakes. I've seen them all the way up Peace River in Alberta. So yeah, we could definitely set you up with hazelnuts. We have quite a few hazelnuts available this year. The
awesome.
hybrid chestnuts, people who buy those tend to buy bigger chunks than those who are buying the hazelnuts. And so although we have quite a few right now, most of the folks who've been buying them buying significant quantities, and poof, they're gone. So if you want the hybrid chestnuts, um, go for those. If you're in USDA zone 6 or warmer, I would say don't even bother with the hybrids. Go right for the Chinese because we know they work. The hybrids are specifically for those who are in colder climes.
Awesome. As always, amazing session tonight. If you guys wouldn't mind, just throw in some ones if you thought that was good, or say thank you or something. Again, we'll get the replay done really early tomorrow, actually. Mark, who's on here with us, he'll get that done and put up there. A bunch of ones from people, a bunch of double ones. Nick, is always really kind. Thank you, everybody. You guys have been great. 2 webinars tomorrow at around noontime. I think it's 12, yeah, right at 12 with Neil Spackman again. This time he's not going to talk so much about his specific operation, but sort of the culture. So how do people fit in his part of the world? And then Mike Warren later in the afternoon about about alternative health, and specifically the cancer conference that he attended with alternative health just recently. And next week, we're going to add a new session on Monday mornings. It's a European that's going to be doing it. And that's going to be at 10 a.m. And a little later in the week, by the end of the week, we'll actually have 2 more sessions that we're doing. And so we're starting to really add some more stuff on all the time.